Okay, so in this lesson, we are going to put together everything you've learned with taking words for chemicals and turning it into chemical formulas with subscripts, as well as everything you've learned about balancing. And this is kind of the culmination of everything we've done. You're taking balancing equations one step further. You're going to take word equations and turn them into chemical equations. When you write chemical equations from word statements, you need to follow the steps below. So first thing you want to do is you want to write out the symbols for elements or chemical formulas for compounds. Now the way you'll know is how many words there are. You're going to use nomenclature rules for determining the formulas of compounds. But there's a way to tell whether it's a word, whether it's an element or a compound. If it's a one-word statement, that means it's an element. And I have a list on the next page of elements that are not monatomic. Okay? But if it says something like magnesium, that's just the element, Mg, that's it. Okay? If it says oxygen, that's just the element. If it has two words put together, that usually means it's a compound. The majority of them are going to be drop and swap ionic compounds. So magnesium oxide, two words, compound. The ones that I can think of that are obviously different is water, which is H2O, and carbon dioxide, which is not a drop and swap. You have to just write the formula by using the prefixes, so it's CO2. Okay, this is a list of the elements that are not monatomic. Right here, these ones you will need to know. I refer to them as the Brinkelhoff elements. They are diatomic elements. We've talked about it before, and the way you know is it's called bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. If you see something that says oxide, that does not apply to being an element. It would be oxygen. Okay, these are two more that you're going to see in the homework packet, but not something I necessarily expect you to remember. So once you identify whether it's an element or a compound, you're going to use a plus sign to separate the reactants. That would be on the left side of the arrow from each other. So the keywords would be something like reacts with. And then a plus sign also to separate the products from each other, and the keyword there is generally and you'll see what it looks like. Then to separate the reactants on the left from the products on the right, you put an arrow, and the keywords are to form. And then you're going to balance as usual by using coefficients. Do not change the subscripts when you're balancing. Okay, so if I look at this, I see aluminum, one word, that tells me it's an element. Reacts with magnesium oxide, two words, that means compound. To form means arrow. Magnesium is one word, element. Aluminum oxide, compound. So what I'm going to do is I'm going to write them here, and then I'm going to have to erase for the next one. So I have aluminum. Notice I did not write 3 plus. I didn't write 3 at all. If it's an element, it's just the letters. There's no numbers. Plus magnesium oxide. That's where I'm going to drop and swap my charges. So when I drop and swap, I get Mg2O2, but it reduces to 1 to 1. It makes it easier to balance. If you want, you can put little lines in front to help you balance. To form means arrow. Magnesium as an element is just Mg. That 2 plus charge only counts when it's part of a compound. Plus aluminum oxide is a compound. That's where I'm going to use my positive 3 and negative 2 and drop and swap Al2O3. Okay, so as an element, aluminum is just Al. As an element, magnesium is just Mg. When you put them with something else, that's when they transfer electrons and get those charges. And now you need to balance this using the subscripts. Balance it by putting coefficients in front to account for the subscripts. There's 2 Als, a 2. There's 3 Os, put an O. 3 Mgs, put a 3. This is understood to be 1. Okay, so that's an example of one where you have both elements and compounds. And I'm just going to, I'm going to erase everything on the slide. Element and compounds, and you only use charges when it's a compound. So if I look at this one, I see two words. That means charges, 2 plus, 1 minus. Reacts with, plus. Sodium phosphate, two words. 1 plus, PO4, 3 minus. To form is an arrow. Cobalt phosphate, 2 plus, and again, PO4, 3 minus. And as a plus sign, sodium chloride, two words, is a compound, 1 plus, 1 minus. So when I do this, I get CO, Cl2, because I dropped and swapped, plus, drop and swap here, Na3PO4, to form cobalt 2 phosphate. So I'm going to drop and swap again, CO3PO4, 2, and NaCl. Okay, so to balance this, I'm just going to kind of go through it real quick. There's 3 cobalts. I'm going to put a 3 here. 3 times 2 gives me 6 chlorides. So I'm going to put a 6 here. That gives me 6 NAs. I only have 3 here, so I need to put a 2. That 2 distributes to everything behind it. So that means I really have 2 phosphorus and 8 oxygens. This 2 also distributes, and so you could even rewrite this as CO3P2O8, and it's balanced with a 1 right there. Stop doing that. Okay, so everything here was a compound, so everything here I had to drop and swap. Okay, next one. Again, 2 words, 1 plus, 1 minus. Reacts with, plus sign. Fluorine, 1 word. That means it's an element, but fluorine is one of my Brinkelhoff elements. Okay, to produce. Potassium fluoride, 1 plus, 1 minus, and iodine. Again, iodine means it's an element, but it is one of my Brinkelhoff elements. So what I have is I have Ki plus element fluorine is F2, to form or to produce, potassium fluoride, drop and swap, and iodine, also one of my Brinkelhoff diatomic elements. So to balance this, I'm going to put a 2 here and a 2 here, and 1s and 1s. Okay, so that one has an example where I have compounds, 2 words, drop and swap, 1 word, I'll use my eraser, 1 word means element, and fluorine is one of those elements you have to watch out for. 2 words, drop and swap, 1 word, watch out for diatomic elements. All right, next one. Hydrochloric acid reacts with calcium carbonate, so I see 2 words. That means I'm going to drop and swap. I'm going to remember my rules. Hydrochloric acid means it's H1 plus dropped and swapped with something on the front of the periodic table. So HCl reacts with calcium carbonate. 2 words. Ca is 2 plus and carbonate is 2 minus. I sometimes forget to do this. Arrow to produce. Calcium chloride, 2 words, drop and swap, 2 plus, 1 minus, CaCl2. Water is 1 word, however, you do have to kind of remember that water is H2O. And carbon dioxide, that's another one that's 2 words. It's a compound, but you're not going to drop and swap. Carbon dioxide is one of those ones that has a molecular structure. So to balance this, I'm going to put a 2 here because of the Cl's. That gives me 2 H's, 2 H's, 1 Ca, 1 Ca, 1 carbon, 3 O's, 1 plus 1, or 1 plus 2, 3 CO's, or 3 O's. So it's balanced. Okay, last one. Phosphorus reacts with oxygen. That's 1 word. That's an element. Reacts with another element. To form. Okay, so phosphorus is one of those ones on the list that I gave you. It's P4 as an element. Not that something I expect you to remember, but I'm telling you it is. Oxygen is one of my Brinkelhoff elements. It's diatomic. To form diphosphorus pentoxide. So this is one where you're not going to drop and swap. It has those prefix names. So diphosphorus means 2 phosphoruses. Pentoxide means O5. Put a 2 here and a 5 there, and it's balanced.